equal to 110. The point estimate is 117.7. The alpha is equal to 10% or 0.1. Let's see what else. The standard deviation. So let's see what kind of standard deviation we're given. The standard deviation is 17, and we are given sample standard deviation. So we are actually going to be doing AT hypothesis testing. So sample standard deviation is given to us. So this test is a candidate for T hypothesis testing. So sample standard deviation is 17.4. So S is equal to 17.4. So we have now written down what we are given. So we have everything. So the next thing is to find out the kind of tests. I already know, as I already said, it's a t-test. What kind of t-test? Is it a T right tail test, or T left tail test, or T two tail test? Okay, from the question, it says, is the population mean greater than? So that question is showing that we are doing a right tail test. So we're going to state the claim. Step one, state the claim. The null hypothesis, colon, mu is equal to 110. The null hypothesis always goes with equal sign. The alternative hypothesis, mu, is greater than, this is what we are testing, mu is greater than 10. So we have written one step. Step two is identify alpha. So alpha is 10%, 0.1. Because it's a one tail right test, we are not going to divide alpha by 2. So we are going to draw a normal curve showing right tail tests. And by the way, it's a t-test, so t alpha is what I'm going to write here. I am not dividing alpha by 2. Another thing I want to find is number 3, which is the critical value, the value of t here. So I can find, and by the way, the sample size in that test is given to us as 35. So let's put in the sample size. So sample size is 35. So we can find the critical value, inverse t. Area to the left in decimal is 0.1, 10%. The degree of freedom is sample size minus 1, which is 34. So we're going to use our calculator to calculate the critical value. The critical value, remember, is the boundary line. The critical value is the boundary line. So I am going to calculate the critical value. I need to pull my calculator up. So I will go ahead and pull my calculator up. So where is my calculator? Right here. All right, so now I'll go back to my whiteboard. My calculator is here. Now the next one is substitute to get inverse t. Okay, so second distribution, number 4, which is inverse t. The area to the left in decimal is 10% or 0.1. Degree of freedom is 35. That is, 34. This is 35 minus 1. So I'm going to paste. So critical value is negative 1.1. 1.31 approximately, negative 1.31. Actually, it cannot be negative. The normal curve is symmetrical, so I have to change it to positive because it's a right tail test. So positive 1.31 is the critical value. All right, the calculator gives me area to the left because that's what it knows, the percentile, but I have to change it to positive because normal curve is, T curve is also symmetrical like the normal curve. So I have done step 3, have calculated the the critical value. So step 3 is calculate the critical value, and I just did that. Remember, there are 5 steps in hypothesis testing. You have to go through all of them. So number 3, T alpha is equal to 1.31. In other words, the boundary line for rejection and acceptance is 1.31. Number 4, step 4, calculate the test statistic. And it has to be t-test statistic. So calculate the test statistics for T, and that is Z for T is going to be T alpha going to point estimate minus the mean of the population. That is status quo over sample standard deviation given to us divided by square root of sample size. If I plug in all that I know, I'll get the test statistics. But guess what? The calculator will get it for me. The important thing is knowing what I am given. So I'm going to actually plug them in because I am given all of them. So I will plug in to get the test statistic. And that is 117.7, the test statistic, minus 110 divided by sample standard deviation 17.4 divided by square root of sample size, sample size. I'm going to not evaluate that because my calculator will give it to me. So I'll quickly go to my calculator and do the T hypothesis testing, right-tailed T hypothesis testing. So where do I go? Go to Start, arrow to Test, and number 2, do a t-test. I'm not given raw data, I'm given the stats. And what is the status quo? That is, what is the status quo, the mean we are actually debating. That's 110. What is the mean of the sample? 117. So 117.7. And the standard deviation is 17.4 given to us. And what is the sample size? 35. What kind of test am I doing? I'm doing a right tail test. All right, so I want to check that I put everything in very well. So I'm going to check back to see that all the things that I am given. Okay, I put everything in. So I'm going to, before I calculate, I want to make sure. And so I don't like to calculate. I like to draw whenever I'm doing a hypothesis test. So I'm going to draw. So I'm drawing for, this is the right tail test, and it gave me the test statistic. The test statistic is approximately 2.5. Just make sure it is approximately 2.98, which is, I can make it, let's see, This is 2 point, I can make it 2.3 approximately. So if I round up, I make it 2.3. So the test statistics is 2.3. All right, so this right here is equal to 2.3. 2.3. Okay, and I can actually write it on the curve too. So I'll bring down the curve and write 2.3 as the test statistic. So where is the curve that I drew? Now I'm actually going to use another pen. So 2.3 falls into the rejection region. So see, it is 2.3. 2.3 falls into the rejection region because the boundary line is 1.31. Okay, so now it's time to make a decision with test statistic. So I'm going to make a decision with test statistic. Now decision time. So step 5, the test statistics falls into the rejection region. So I do not have enough evidence to accept the null. Okay, do not have enough evidence to accept the null. I do not have enough evidence to accept the null. I'm not saying that I reject the null, but the important thing is that from the evidence given to me, from the sample given to me, it hasn't provided me the enough evidence to accept the null. So I am saying that from this conclusion, the population mean is greater. The population mean is actually greater than 110. The population mean is actually greater than 110. So from the test statistics, I have rejected the null. I didn't accept the null. Okay, let's go back to the calculator and get the p-value. So let's get the p-value. So if we look well, we see that the p-value is actually let's see what it is here. The p-value is approximately 0.9. Let's see what it is. 0.007. So the p-value is so insignificant, 0.007. So now, according to p-value, so I'm going to use p-value is 0.007, 0.007, 0.7%. 0.7% is less than alpha. Alpha is 10%, 0.1. Therefore, p-value is less than alpha. So p-value is less than alpha. P-value is less than alpha. So this is a candidate to reject, do not accept the null. So I do not have enough evidence to accept the null hypothesis. Just like the test statistics rejected the null, the p-value also rejected the null. The test statistic rejected the null, therefore the p-value also rejected the null because the p-value is less than alpha. Also, the test statistic fell into the rejection region. So we conclude that we do not have enough evidence to accept the null, the status quo. So now you go to those who invited you and tell them that you do not have enough evidence to accept the null, the status quo. So the next thing you want to do is tell them that they need to change the status quo because actually greater is no longer working. They need to change it. They need to find a change. It's no longer working. Okay. So that is an example on, this is an example on hypothesis testing. We have applied the 5 steps. Don't forget that every hypothesis testing, you have to apply the 5 steps. Apply the 5 steps of hypothesis testing. So this is example 1. Well, the next example we're going to do is confidence interval. So we just did an example on hypothesis testing. So we're going to, the next one we shall do is on confidence interval. An example on hypothesis testing. So the next example is confidence interval. So let's clean this board so that, so you see that whenever you are given, you have to make sure that you state the claim, do all it takes to do a good hypothesis testing. You are given everything, all the variables. Okay, and you cannot use confidence interval to do this hypothesis testing. Why? You cannot, because it's a one-tailed test. You do not use a confidence interval to do one-tailed test. Then let's find out other things we are given. All right, so the sample standard deviation is found to be 8. So this is going to be 80 confidence interval because we are only given the sample standard deviation. And as we said the other day, we're not expecting population mean and other things. Otherwise, what are we going to prove after we... So we're given sample mean, sample standard deviation, sample size. So we're also given sample size of 21 for A, question A. And we are told to do a 96% confidence interval. So 96% confidence interval, which is 0.96. This question says, calculate a 96% confidence interval. All right. Okay, so let's see what other questions here. Okay, so let's calculate the confidence interval. You want to know how to make sure you know how to write the formula. To calculate the mean of the population, the equation is you're looking for the interval estimate. So the point estimate plus or minus margin of error. And margin of error is T alpha over 2. In every calculation of confidence interval, you have T alpha over 2, and then sample standard deviation divided by square root of sample size. All right, so your calculator will give you all this, but you want to actually make sure you can calculate the formula. You can plug into the formula, just in case you're told to do the work without calculator. So now I can actually plug in this into my calculator. And before I do that, I can actually draw a number line. So I'm going to draw a number line. Maybe I have to move this a little bit up. So draw a number line. And then I want to show that the confidence interval starts from the lower bound to the upper bound, where the midpoint of that confidence interval is the point estimate x bar. And when I finish, I will also be told to find the margin of error, the distance between the upper bound and point estimate. Okay, so what I'm going to do is pull my calculator up and plug in what I'm given. So every confidence interval is a two-tailed confidence interval. If it is a hypothesis testing, then you will be asking if it's one tail right or one tail left or two-tailed. But every confidence interval is a two-tailed confidence interval. Okay, so now I want to go to go to start, arrow to test, and I'm doing a T confidence interval. So I'm going to look for T interval. T interval is number 8. And then I am given all the things that I need. I'm given statistic. So the sample mean or point estimate is 108. The sample standard deviation is 8. The sample size is 21. Okay, so that's all that I'm given. All right, so that's all I'm given, but I'm also given the confidence interval is 0.96. 0.96, cannot put it in percent, you must write it in decimal. So I'm going to calculate the confidence interval with all the things given to me. Therefore, my calculator gave me that the lower bound is 104 and the upper bound is 104.17 and the upper bound is 111.63 or 83. Okay, so 104.17 or 17 to 111.83. So I'm going to draw a number line. I did already. So and the center is 108. And right here is 104. This is 111. This is, let's go back and get the decimals. The decimal to the left is 0.17, and then the other one is 0.03. So 0.17.03. 17.03. All right. Okay, so at this point now we can make a decision using what we are given. So at this point I can say that I don't know what the mean of the population is, but what I do know is that mean lies between the lower bound 104.17 and the upper bound 111.03. So you can start by saying I am 96% confident. You cannot be more confident than the confidence level given to you. I'm 96% confident. I am 96% confident that the mean of the population, that mu is equal, is or lies between, I can just say equal to plus or minus the sample mean 108 plus or minus, and then I can just get the margin of error. So the margin of error is 111.03, subtract 108 from there, and I have 3.03 plus or minus 3.03. So the sample mean plus or minus 3.03. Sample mean plus or minus 3.03. So I do not know what exactly is the mean of the population, but using what I'm given at 96% confidence interval, I'm saying that if I'm given 100%, if I keep testing, I will find that the mean lies between 108 plus or minus the margin of error, 3.03. Okay, so there are so many ways you can say it, but make sure you conclude. You have to write a conclusion. It's not enough to just, it's not enough. So you have to write a conclusion for your test. Okay, so now we found the margin of error this time, ME is equal to 3.03. Well, let's go back to the question. When we go back to the question, they're asking us to do some manipulations. So they're asking, so if you can do one, if you can do one of these, you can do all of them. So all you need to do now is change the sample size to 15 and everything will be the same. So let's do that. Let's do confidence interval and change the sample size to 15. And when we finish, we shall find the margin of error. And we shall also do C, calculate the confidence interval, find the margin of error. And when we finish, we shall see what is really happening when the margin of, when the confidence interval is increasing like it did in, decreasing from, like it did from A and C, what happens to the margin of error? When the sample size decreases, what happens? So this time the sample size is going to decrease. So let's decrease the sample size to 15 and see what happens. And then we check the margin of error. So let's do that. We are changing the sample size. So we go back to STAT, arrow to test, go down to number 8. Do not change anything except the sample size. Change sample size to 15 and do the same confidence interval with 96% confidence and see what happens to the margin of error. So how did the margin of error change? So the margin of error changed from, so actually the margin of error right now is approximately 4.7. So margin of error increased when the sample size decreased. So as the sample size increases, the margin of error decreases. Let me say it again. As the sample size decreases, the margin of error increases. That's what I said, the law of large numbers. The smaller the sample size, the larger the error you can make. So it contains a lot of area because the sample size is decreasing. That is why you have to maximize the sample size as much as you can. The smaller the sample size, the greater the margin of error. So that's what happened in B. Okay, so question C. In question C right now, we are going to decrease the confidence interval, and we keep 21 as the sample size. So let's see what happens. What happens when the confidence interval decreases? What happens to the margin of error when confidence interval decreases and sample size is the same? So let's do the same thing. Go to start, arrow to test, and we do T confidence interval with a decreasing confidence level, which is 0.9, this time 0.90%. And we want to calculate, no other thing is decreasing, no other thing changes except the confidence level. So we're going to put back sample size to 21. So sample size is 21. And what is going to happen? What is going to be the difference? So we're going to calculate. We want to know what happens if everything is the same, everything remains the same, and only the confidence level is changing, decreased to 6%. What actually happens to the margin of error? Okay. So the confidence level decreased by 6%. The margin of error is approximately 3.01. So the margin of error is approximately 3.01. So a little bit different from when the confidence interval was 96%. So it's smaller. So the margin of error gets smaller as the confidence interval decreases. All right, so actually we are going to stop here because the majority of the questions in that test are hypothesis testing and confidence interval. I did 2 examples, and these 2 examples summarizes the test. So I am hoping that you do well. Test starts in 2 days. Test starts on Wednesday. I will still be in my office on Wednesday to see if anybody has questions. So if you have a question, you can come in and ask the question. Remember that all the video sections are in Blackboard Collaborate Ultra. Also, there are authors videos